Hello, folks, and thank you guys for checking out our 2020 annual meeting this year via PowerPoint. My name is Dana Boyle, and I'm president of the Northern Neck Vegetable Growers Association, and I welcome you. We would love to be able to be with you all this year in person to fellowship and have lunch together and all that fun stuff. But since that could not happen, I will instead take this time to thank our extension agents, Stephanie and Trent, for putting together this information pack program. For those of you joining us that are not members of the Northern Neck Vegetable Growers Association, please consider contacting me or one of our members or one of our extension agents to find out more about our educational programs, our educational trips, our scholarship, and more. We'd love to share more information with you about our fun association. At this time, I'd like to thank our sponsors shown on your screen for their support of our 2020 annual meeting. Please fill out your survey at the end of the presentation to have your name entered into a drawing to win a gift card sponsored by these businesses.
Hello, this is Tom Kuhar, and this presentation is on managing stink bugs on vegetable crops. First, let's talk about what stink bugs are, because there are hundreds of different species of stink bugs found in North America, including Virginia. Many of the species occur in this state, but there are many stink bugs that are native to this area, a lot that have a pretty broad host range and feed on a lot of different plants, such as the brown stink bug you see up in the top, and the green stink bug up on the right, the red shoulder in the bottom right, and the dusky stink bug. These are bugs that feed not only in trees, but on a lot of different plants and weeds and things like that, including vegetable crops. In fact, we actually put together a field guide to stink bugs. They've actually had a second edition of this come out, but this is a little handheld flip guide that this kind of allows you to identify the important stink bugs that we find right here in the mid-Atlantic U.S. So another stink bug that occurs a lot on vegetables, but this species is a little bit different. This one is the harlequin bug, and harlequin bug is a specialist, whereas unlike the other stink bugs that have a broad host range and they can move about from plant to plant, these pretty much stick on brassica plants. You will occasionally see adult harlequin bugs when no brassicas or cole crops are around actually do a little bit of feeding on some other vegetables, but they really don't like it, and they need brassica plants in order to complete their development. So these are strictly found on things like broccoli and cabbage and collards. I'd also like to point out that although there are a number of stink bugs that are plant feeders and are considered vegetable pests, there are just as many that are quite beneficial and play a big role as biological control agents of a lot of pests. You can see the Florida predatory stink bug. That's the orange and black showy one up on the left, and ironically it's actually eating one of our more important pest stink bugs. Perillus is another stink bug. That's the one on the top. And that one, you see it often feeding on Colorado potato beetle larvae. And then the spine soldier bug you see on the bottom. And these are important predators of caterpillars as well as things like Mexican bean beetle larvae. So all the stink bugs have pretty much a similar life cycle, and that is that most of them will overwinter as an adult and emerge sometime in the spring and lay their egg masses, which is kind of like a raft of little tiny barrels. All stink bug eggs kind of have that same resemblance. And these will be deposited on leaves. Typically, a lot of stink bugs lay their eggs in trees and have their first development, or their first eggs hatch on trees, and actually they may go through an development. But you also see eggs deposited on vegetables and things like that. So eggs are deposited and they hatch in about a week or so. And the little tiny first instar nymphs of stink bugs will typically stay right on that egg mass. They don't do any leaf feeding. and they are basically sitting on that egg mass together as a group. And they're actually acquiring important endosymbionts that the mother stink bug left behind, and they often need these endosymbionts in their gut in order to digest plant matter, which they're going to feed on later as they go through their molts. So you'll see up to 5 molts of the stink bug nymph, and then ultimately becoming an adult. So this is the kind of the baseline life cycle of most stink bugs. They may go through one, or they may go through multiple generations of this in a single year. So now let's talk about how stink bugs feed. They all have piercing, sucking stylets. So these are mouth parts that they're not going to do any chewing. You're not going to see holes chewed by this insect, but rather they will stick their piercing stylets of their proboscis into plant matter, or if they're a predator, they'll stick it into another insect. But you'll have enzymes that will come out of one of these stylets that will liquefy the tissue, and then the other stylets can suck it up like a straw. And what is left behind is sometimes seeds that don't develop because the stink bug fed on them early, or you will have marked up areas where the stylets were inserted, and that becomes kind of unsightly lesions on the plant, as you see on the right on the tomatoes, or from the harlequin bug nymphs on this brassica plant. Well, stink bug pest management became a lot worse in the 2000s, and that was because sometime in the mid-1990s, a stink bug was transported from its native land in China, from Beijing, China, into the U.S., landing, probably coming in through Philadelphia and ending up establishing in Allentown, Pennsylvania. And this was the brown marmorated stink bug, which was accidentally then introduced into the U.S. sometime in the mid-1990s that they can best recollect with the records. Well, the brown marmorated stink bug quickly became an invasive species. Its populations increased dramatically and spread through the mid-Atlantic U.S. and is currently in much of North America, as well as throughout Europe now. And this is it is just like all the other stink bugs, goes through a very similar life cycle. It's a little bit larger than a lot of our stink bug species, so it's got a little bit larger proboscis, but it is another stink bug that basically got added to our species complex of stink bugs that we have. So as I was alerted to this as a vegetable entomologist in the early 2000s, I was left with the question, so what's the big deal about another stink bug species in our environment? We already had several different species, and we already somewhat had a good handle on how to manage stink bugs. So what's the big deal? We got another new species. Well, we quickly found out what the big deal was, and that is that brown marmorated stink bug became a major nuisance in human dwellings, and in fact that's how most people across the country are aware of what the brown marmorated stink bug is. It's that stink bug that gets into the houses. The bugs will enter in the fall, but can kind of leave their overwintering aggregations and fly around houses during the wintertime as well. The bugs will want to get out come springtime. But this is a major nuisance to a lot of people, particularly in the fall when these bugs are aggregating on the sides of houses and things like that. This is the first species that we have ever had of stink bugs that has this behavior of overwintering in houses. So that's a big deal, and their sheer numbers are almost at ridiculous levels. So high densities of this pest, and the fact that it can overwinter in human dwellings, which actually enables it to survive very cold winters, much better than the other stink bugs that are overwintering outside. But the other important big deal about brown marmorated stink bug is that it was a tremendous agricultural threat that we had never seen before from a stink bug. The damage that it did to tree fruit in 2009 and 2010 had never been seen before by an agricultural pest. Fruit that were dropping from the stink bug feeding on them, or fruit that were harvested, and unbeknownst to the grower, stink bugs had fed upon them. So when the apples were stored and later cut into, they showed some corky areas from where the stink bugs had fed with their stylets, and this was really bad for the quality of the fruit, and just tremendous losses to tree fruit. But we also saw very high densities of brown marmorated stink bug aggregating on various vegetable crops, including sweet corn, tomatoes, peppers, beans. Just seeing stink bug numbers like we had never seen before. Among the vegetables that are attacked, and we did some early research on which ones that the brown marmorated seemed to prefer and which ones showed a lot of damage, and is basically what I had mentioned before. Sweet corn is, especially when the kernels are soft, very, very attractive host. Bugs love to feed through that husk right onto the kernels. You can see the damage circled in the center slide there. That was from stink bug feeding. And then the marks that they leave on crops like peppers, tomatoes, and beans from their feeding. Well, the one thing that we keep seeing is that our species complex of stink bugs, at least in the last 20 years, has really been undergoing a lot of change. We are adding species. So the brown marmorated, obviously one that came from Asia and now is a well-established invasive species. But we have like the southern green stink bug, which folks in the deep south have battled with for a long time. This is an important soybean stink bug, probably the #1 stink bug found on soybeans in a lot of the south. And this is a species that we never dealt with in Virginia, but over the last couple of years, we are seeing it in the warmer climates of Virginia, south side, and in 2020, this was the most abundant stink bug that we found on our crops, including edamame, and we'll get into a trial that we did a little bit later on that crop. But so not only do we have brown marmorated that has just taken off, but we seem to be getting some stink bugs that we've never had before, including this southern species. So without a doubt, stink bugs are a major concern for vegetable growers now because of all those reasons. So what do you do about it? A lot of growers, obviously, you're reaching for some kind of insecticide to help prevent this injury on these valuable commodities, these vegetable crops that we're growing. In 2017, I published a review article of all the insecticide work that had been done on brown marmorated stink bug, kind of being the hardest one to kill. And really the review of the literature basically showed that the pyrethroids pretty much are the most efficacious and the most widely used insecticides. Neonicotinoids, especially dinotefuran, which is found in venom and scorpion insecticides. It's also a really good product. And there's some additional insecticides like some older organophosphates and carbamates that also work very well against stink bugs, but they may be limited on the different vegetable crops that you grow. So that is pretty much it. Going through the literature and a lot of tests, you're left with these insecticides as kind of being your most effective. So pyrethroids being the cheapest and the option that just has a lot of different products that are available. A lot of growers use pyrethroids for stink bugs. One of the problems, though, and is kind of illustrated in this efficacy trial conducted near Whitethorne, Virginia, where this was peppers, and we sprayed them 4 times, approximately weekly through the months of pretty much through the month of August. And what we're looking at here is the amount of stink bug injury found on the pepper fruit and the untreated control on the top. So that averaged anywhere from 15 to 40% of the fruit had stink bug damage. And then 3 pyrethroids that were applied, Mustang, Max Hero, and Baythroid. And you can see all of them, giving you anywhere from 50 to 75% reduction in damage, which is very good for just 4 weekly sprays. However, the column to the far right shows what it did to green peach aphid numbers, and as you see in the untreated control, there were hardly any aphids, roughly 3 per 20 leaves, which is not a problem at all. But you start spraying pyrethroids, particularly Hero, which has got 2 different pyrethroids in it, and you see aphid numbers just going off the charts. And What this does, as we go to the next slide here, is shows what happens in pepper when green peach aphids explode. Well, one, this aphid is resistant to pyrethroids, so you're not going to kill it when you spray those products. But what you are going to kill is all the natural enemies that eat the aphids, and the aphids will just take off, explode, and you see from their honeydew excrement that you'll have sooty mold growing on that, very sticky fruit, and possibly even unmarketable fruit. So by controlling stink bug, you ended up with a problem that might have been even worse. So therein lies the issues with stink bug pest management, that the products that work the best and growers use tend to cause some other problems as well. Well, this is a rather large table. It's a lot to take in, but it was a lot of work that went into it. And really what it summarizes is the performance of insecticides across multiple tests. So there had to have been at least 4 insecticide efficacy experiments where we got the average % control. And this basically just shows a rundown of all these products and how well. So these are all things that did show some kind of level of control of stink bugs. And there's a lot of products and a lot of selection there. A lot of neonicotinoids and pyrethroids and some combination products that have a little of both. So this might be something very useful. I wouldn't hold the top 2 are the best. I think there's a range of everything over 70% is probably some pretty good materials, and things like that. But the other thing I want to show you with this table is I already mentioned the problems with spraying pyrethroids, just straight pyrethroids, that you're very likely going to get an aphid explosion in a lot of different crops, especially peppers. So among this table, there are products that actually provide good aphid control. All the neonicotinoids or products that have neonicotinoids in them, some combination products like Brigadier or Leverage 360, Endigo, these have neonicotinoids plus a pyrethroid, and these will all control the aphids. So you're left with now products that can control both the stink bugs and the aphids, and at least alleviate that outbreak problem. But what we've been working on for about 10 years now is there anything that's better? You're basically saying pyrethroids work the best, neonicotinoids work pretty well, and will control aphids. But some growers can't use neonicotinoids. There's a lot of regulation going on with the use of those products, and some, that's an option that they don't have. And as a whole, are there any better solutions? Are there things that are a little more IPM friendly, a little less disruptive on pollinators and things like that will actually provide control of stink bugs? So we've been doing a lot of work on searching for these types of products. One thing important to know is that stink bugs are controlled naturally by these little tiny egg parasitoids that will sting the egg mass, and from those eggs then we'll develop a new parasitoid wasp which will then hatch out and find some more egg masses to sting. Well, these natural control agents provide very effective control of our native stink bugs. In fact, we don't see huge problems with brown stink bug, red-shouldered stink bug, or green stink bug often because these parasitoids do a heck of a job at keeping populations in check. We have issues right now with brown marmorated stink bug because the parasitoids just do not do well on this Asian species of stink bug. But nonetheless, egg parasitoids are something we should keep in mind when we're spraying insecticides. We don't want to eliminate them from the system because they're doing very good work. So I'm going to review some of the little more IPM friendly or a little more selective insecticides that we've been evaluating for stink bug control. One of them is Transform, and this contains the product sulfoxaflor, which is very similar in mode of action to the neonicotinoids. And there was a trial that we conducted near Blacksburg on peppers where we sprayed weekly 4 times. And we actually, although it wasn't significant, we didn't get a ton of stink bug pressure in that trial. It did appear that, we're seeing a little something with the transform. We had reduced damage, but again, this wasn't significant, wasn't really convincing data, but maybe promising for something like transform, which is a little bit softer. Another insecticide that's relatively new is Harvanta, and this is a diamide insecticide, group 28. So a lot of vegetable growers are familiar with Coragen, which is a diamide, and here's another diamide now, Harvanta, that has a lot broader pest spectrum and possibly even some activity on bugs like stink bugs. So, but it's a lot safer on the natural enemy. So, how has Harvanta fared out? Here's a trial in 2016 on tomatoes conducted at Whitethorne. We actually sprayed 6 times through July and August, and again, not a ton of stink bug damage this year. Only 9% of tomato fruit had injury in the untreated check, but Harvanta basically cut that damage in half and seemed to perform comparably to the diamides and the pyrethroid bifenthrin. Another new insecticide is Savanto, and this one is really used for sucking pests like aphids and things like that, but it's got a mode of action that's very similar to neonicotinoids, just like the transform product, but a little bit different mode of action, and it's a lot safer on bees, and we have evaluated this one as well. So here's a tomato trial in 2018 where we sprayed 6 times, and to the right are the proportion of harvested fruit that had stink bug injury, and you can see this trial had Savanto. Closer, by the way, is the same as transform, so when you see that, that's the same as transform. And in this trial, I wanted to point out that the closer or the transform seemed to perform the best among these insecticides, and Savanto gave a little bit of control as well, as you see in the second harvest date. So we're seeing a little something with these products, that they may be some options for stink bug injury. Here's a trial that we conducted on green beans, and it had a lot of these same products: Transform, Harvanta, Savanto. Assail, by the way, is a neonicotinoid that is about 100-fold less toxic to bees than other neonicotinoids, so it's a little bit more IPM friendly, pollinator friendly than a lot of the other products, so we put that in there. And we tested it against Hero, which has 2 pyrethroids and a pretty good insecticide. So this was one application sprayed during potting stage of the beans at about pin stage. These were green beans. And the one thing we showed, this was conducted on the Eastern Shore, is that all of these products reduced potato leafhopper numbers. So that's good. It's not surprising. Potato leafhopper isn't as hard to kill, and all these products are really good on that insect. But what did it do to prevent stink bug injury on the pods? As you see to the right, you could have flattened pods where the seed didn't develop, or you could have some scarred areas. And really none of the more selective IPM friendly products really reduced stink bug injury to the pods. Only the pyrethroid worked, Hero. So we're getting a lot of mixed results with some of these softer chemistries. It's a bit frustrating and a bit challenging to find something that's both IPM friendly and will control stink bugs. Well, something that we have learned in recent years as we are getting into some edamame research is that stink bugs are a major pest on this crop. They love it. All the stink bugs that we reviewed earlier in this talk seem to come to edamame and feed on it. You see the injury that they do to the seeds inside the edamame pod. You don't want to find that when you crack open one of these pods when you're ready to eat it. So you see both brown marmorated on the top left. These are green stink bug nymphs in the middle, and then the southern green stink bug nymphs from the Eastern Shore in the bottom right. Well, we are running insecticide trials in this crop as well, edamame, and here's a recent trial from this past fall. conducted in September, and you see some of these same products we've been looking at: Transform, Savanto, Harvanta, and there's the numbers of stink bugs. In kind of the September 21, we had a significant reduction in numbers of bugs on the plants when we sprayed all these materials. But when it came down to looking at proportion of stink bug damaged pods, again, we did not get anything significant that reduced pod damage, which, by the way, was about 40% of the harvested edamame pods had stink bug injury to the seeds. By the way, there's a new product, Spear T, that is in this treatment list. This is actually a new, really neat novel insecticide that is kind of modeled after a spider toxin. So it's basically using the same poison that spiders have to kill their prey, and now formulated into an insecticide. And we're looking at different ways to use this, and we really didn't get that effective control of this using this insecticide in this edamame trial. Well, I'm going to finish this talk talking about stink bug control for organic growers. So it's already a challenge for conventional growers. You're left with pyrethroids and neonicotinoids, and you may not be able to use them, or they may cause problems. But what does an organic grower have? You grow the same crops, you get the same injury. So we did a lot of work. I had a graduate student exploring everything under the sun that organic growers could use. And I tell you, the bottom line is we tested all of these things, from neem oil, isoduractins, pyrethrins, spinosins, various salts and soaps and things like that. And none of them worked in the field. We could get effective reduction of bugs with some bioassays in the lab, but man, when we would take that to the field and spray peppers or tomatoes, we never got a significant reduction in stink bug injury with any of that stuff. And I think it's a waste of money to be spraying that to control stink bugs. It just did not get the job done. However, one thing we did find that did work well, worked significantly well, was the use of kaolin, which is basically a real particulate fine powder clay found in the products around. And growers of tree fruit and even fruiting vegetables may spray this anyway to prevent sun scald. And it is a product that a lot of organic growers are familiar with. We got significant reduction in fruit damage. Stink bugs do not like being on kaolin. They don't like walking on it, or they may not even recognize it as their food plant. And because the bugs don't get on the plants, they don't cause the injury to the fruit. So we have seen very good control of stink bugs with the kaolin. And here are some of the slides that kind of show this. This was weekly sprays on peppers. By the way, we also looked at essential oils as kind of another organic control product. And the gray or the white is the kaolin. The red is the essential oils, and the blue is the untreated control. And really, can see the level of control that's provided by the gray or the kaolin. And these are different harvest dates that you see on the x-axis of these two trials that were conducted. So that wraps up this talk. So in summary, conventional growers really have a lot of pyrethroids and neonicotinoids that are the most effective insecticides to use for stink bugs. Fortunately, there's a lot of these types of insecticides that are registered on vegetable crops. Some more IPM compatible, more selective insecticide options that maybe warrant some more consideration include Transform, Savanto, and Harvanta. And for organic growers, we highly recommend kaolin as probably your best option, and maybe none of those other types of organic insecticides. Well, that's all, folks.
Please take a moment to complete the brief survey linked below. Your responses will give us a better understanding of how we are doing and how we may better serve your needs in the future. To access the survey, you may scan the QR code on the left using your smartphone's camera or QR code scanning app, or enter the link on the right into your internet browser. Those who complete the survey have the opportunity to enter a raffle for the chance to win a Visa gift card provided by our generous sponsors. Thank you.